call it the we're just about the remember we were talking about Bernoulli's principle? And suppose those are the same diameters,
right.
So the velocities are the same? And you call that P1 and that P2 and that height's H.
Right.
Then the kinetic energies per unit volume cancel out.
Yeah, right, right.
And so you just get this equation.
C1 minus P2.
It's equal to P2 plus mgh.
Now,
Now, the velocity could have been zero, right? There's nothing, they cancel out, irrespective of whether they're identically zero or they cancel out.
Right.
So, I mean, it seems like it's predicting two possibilities. One, it could actually be moving, or it could just be balanced at rest by that pressure. So there must be something more subtle going on, like there's some sort of friction and it's there must be some tiny amount of friction. In other words, there's two possible interpretations here. They don't care whether the velocity is actually zero or if it's non-zero, it cancels out.
Yeah.
And the velocity could be 100 meters per second, right? Or zero. It doesn't. The same equation applies.
Right.
So I kind of went to a deeper. So I'm once again confused. Remember the original thing, right? We talked about was remember Bernoulli's principle. If the kinetic energies are equal, this is at ground here. There's no mgh here. And if the kinetic energy, because they have the same, suppose they're the same diameter, then the velocities are equal, so the kinetic energies will cancel out.
Right.
The kinetic energies per unit volume.
I don't necessarily understand how the velocity equal that's moving up and should slow down.
Well, because their radii are the same. So the continuity equation, remember. So if their areas are the same, they'll cancel out. So the velocities have to be equal.
Yes.
And the original, this is the second thing I'm making now, but the original thing was, I hadn't really thought of that case. And I guess my comment was, normally your intuition, when something moves up, it slows down, right? But somehow the pressure is adjusted in such a way, this pressure is bigger, just the right amount, so it doesn't slow down. That was the intuition, so I thought that was it. But then I thought, thinking about it more carefully, the velocity could be identically zero, or it could be 20 meters per second. The same equation holds, but those are two different physical situations. So there must be something more subtle going on. Like there's some extra, there must be some extra, this pressure must be a little bit bigger than that, and it's somehow balancing friction between the walls of the tube and water. Maybe it's making two.
First, wouldn't the friction be the same throughout the whole tube?
So
what did you say?
Well, yeah, so it's not making any difference between water moving at rest, right? It could just be balanced, right? Not moving at all. So the same equation predicts it could be moving with any speed you want. The speed of light, I mean, it could be anything. I'm not sure, that doesn't make sense though.
I mean, the continuity equation is constraining it, so like if this much mass goes through this part, this much has got to go through this part.
That's right.
So I'm not sure I'm getting the subtlety.
Well, I guess the same equations, the kinetic energy is canceled out regardless of whatever the speed was.
And that I'm okay with, I think.
So if you put in speed to zero.
If I put in speed to zero, then I have no mass coming through, so no mass has to leave here.
Right.
That works.
So the same equations applying to at rest and moving with any speed you want.
Yeah.
But you would think the faster it moves, the more friction would occur.
We're ignoring friction, right?
Right.
We're ignoring all that fluid dynamic stuff.
So you're saying it's okay?
I don't know.
It just seems odd to me that the same equation would predict could be at rest or could be at any speed you want. I find that unusual. You would think physically if it's moving there'd be more friction between the water and the walls. I know we're neglecting friction. But
right. So isn't that why it works?
So I think that somehow you'd have to add some extra pressure to that P1 to actually balance. It would depend on speed too.
Right.
So it's kind of an unrealistic idealization not to include friction. That would kind of that kind of makes a distinction between at rest and moving that.
Yeah.
Because it didn't make sense to me intuitively that it should be no difference if it's at rest or moving.
Right.
And we're making an unrealistic idealization and neglecting friction.
I see.
That would presumably distinguish those cases.
Yeah. Let me think about it.
Right. No, that was,
I think I want to shift over a little bit.
Sure.
We can move, even if you move that, yeah. That's great. Or if you do that.
She was like,
Well,
Oh,
let me find my two Twizzlers.
no, I'm good.
Because I bought them, they were really big, and I don't expect to
Really?
eat all these yet.
everybody says that.
I have, I bought these too. So,
I can easily do that.
yeah, I'm telling, oh, I could easily eat
You're not
them,
overly sweet.
but I definitely didn't want
Take
to.
that.
Just one?
Yeah, no, I'm good.
You can't just have one.
Let me see if I can. I'll go with
I have a blueberry in my mouth.
Your voice sounds worse than yesterday.
All right. So, kind of funny you guys looking at me like this, but
How you want us to arrange?
Huh?
You want us to move?
No, it's good.
Okay.
Where's it just for the camera?
Oh, I think.
Okay.
But I don't know. We just very good. So probably meet one more time,
Mhm.
and then I'll bring the paperwork next week. So what you guys should do before next week is fill out those Google sheets.
All right. He said that we were gonna do it after finals, so.
Right, yeah. That's cool. As long as you, basically you're gonna fill out the sheets and then I'll take them home and I can, so.
This is our third meeting. Third, fourth.
Yeah, I think it's the fourth.
Fourth.
With the initial
We're
meeting.
sitting over there twice.
twice.
Yeah.
I missed one.
You missed one.
Here.
Yeah, and then again, when you're filling out the sheet, right, there's this time that we meet, there's also the time when you're reading the papers, and that kind of thing too. So.
Do you think we'll meet again next Wednesday? Is this building open next week?
Yeah, teachers still have to come in and put their grades on this month.
Would think so.
Yeah, unless we wanted to meet in Hyde Park.
Was that what we said?
I think we were talking about that.
What's more convenient for you?
Yeah, whatever.
It doesn't matter. I'm available in the morning. And then something's happening next Thursday. I'm not available. Okay, so yeah, I'm available every morning
Okay.
after, at probably 9 o'clock. Every morning I'm available,
You're right on.
except Friday.
No, I think it's okay.
So
Are you still in
Monday-
school now, or
I'm still going to school, but I
Is this
mean,
your
I can do
finals
it in the
week?
morning.
is your finals week end this week?
Finals week ends this week.
So next week you're
I'm still.
there, but
because
you're
I'm
not teaching.
right. I'm not teaching now.
You're not.
So,
Not teaching now.
so I'm just hanging out.
Okay.
I mean, I'm doing the chair stuff. But yeah, so 9 o'clock's good for me. I mean, I come on the way in. And
What day? Any day but Friday works for me next week.
I can't do Thursday.
What about 10 o'clock? 10 o'clock?
Every day.
10 o'clock's good.
10 o'clock's okay.
9:30.
It means I get to work a little later than I maybe should. But it's okay.
No,
We can do 10.
9:30 work?
9:30. How about 9:30?
Okay, what day were you on?
I don't know. Oh.
Any
How
day
about,
but
could we do
Friday.
Wednesday?
That works.
Is that that's
The Wednesday's good.
At 12.
Wednesday the 12th?
At 9:30.
9:30.
Where?
I really think this place is gonna be open because grades are due to 12.
And we're gonna do Hyde Park.
If, I don't know.
Oh,
Is that
okay.
good?
Yeah, sorry. That's not sure.
Flexible, whatever you guys want. What are we gonna do?
I guess Hyde Park, so that's.
So we can
your
read
turn.
in the Reynolds Club, there's no ID required.
What-
Reynolds Club? Oh, that's,
57th and University.
What side of Woodlawn is it?
Say again.
What side of Woodlawn? Is it going towards Cottage? That side of Woodlawn?
West of Woodlawn University. What's it called?
What, yeah, we can meet in the lobby. There's like chairs, like a big hallway. So it's like,
Is that Reynolds with a Y? REYNOLDS?
yeah. It's like the corner, let's see. This is, let me think.
51.
57th and University.
57th and University. It's the corner of the quad, basically.
Oh, I think I know.
They don't get people from the community go there. You don't have to be a student or anything.
Yeah. Do
Isn't
people
that
meet
meet
there?
Starbucks?
Say again?
Do people meet there for like to go to the train or to the airplane?
Mm-mm.
Airport.
They might. I don't know. It's possible.
It's by that Starbucks, not too far from that Starbucks, right?
But no, that's over here. That's on the other side.
50.
This is the lake here.
Okay. I'm looking at it.
This is the lake. So 57th runs this way and University runs this way. You want to go that way? So,
I know the bookstore is on 57th.
Yeah, that would be Ellis.
so
Oh, we'll figure it out. We'll Google it.
but yeah, so the lake's this way. So 57th is 57th's here, and then University is this way. So, by the way, Stony ends at 57th. Stony Island. That's basically almost where it ends. Not quite, but
Oh,
so if you're coming down Stony Island, you just go down.
okay.
And lots of times you can park on 55th
So you know where Ray is? Ray is Kimba.
Uh,
Okay, and so it's gonna be west there.
The restaurant's one there.
Yeah, you're actually going east, so you're gonna go west.
Okay.
Okay, that sounds good.
There's like a large open area with like couches and chairs.
Okay.
There's also I'm not sure if they're open. There's that lunch
Okay,
place.
okay, yeah,
It's probably it's like a bagel place or something.
okay, yeah, sounds good.
Okay.
So that's
All right, cool.
9:30 Wednesday.
9:30 Wednesday.
We actually put that down on my phone.
All right, so should we talk about the paper?
Sure.
Do you guys want to, I don't know, just, what do you think?
I think of this.
So Wednesday, 9:30.
You know what I thought, honestly, is it's interesting how things, how common sense is relative.
Mhm.
Because as I'm reading this, it makes perfect sense that you would assess what people know and try to make bridges to
Yeah.
what they know, to new
Right,
understandings.
right,
But then obviously, you all are, you're physicists, and so there are things that seem to be very common to you, and
right.
then you hear people say things like whatever silly things we say, and it's like, what? And so it,
Yeah.
the whole idea to me was like, it seemed really intuitive that
Uh-huh.
you should assess what people know,
Right, right,
and
right.
then you should
Build
build on that,
Mhm.
Yeah.
Do you
Uh-huh.
appeal to how they think about things? Do you try to also find out how a person thinks about things? Is that important? Discover the way. Is that important?
I think, what, can you explain what you mean by,
How a person arrives to a conclusion. I mean, we might come to the same conclusion, but I thought about it this
Right.
way. You should thought about it this way.
Uh-huh.
Is it important to know or to learn how the path that
Yeah.
the student typically takes when they think about things?
Uh-huh.
I guess know the student thinking style.
And I think that's really relevant to our discussion, right? Because last time the paper we read, we talked a little about this idea of misconceptions, right? And I think we talked about a specific example with the car and the
Yes, right.
and the truck.
Comes up here.
It comes up here too, right? So we talked about, so the car hits the truck, or the whatever, the truck.
Doesn't matter which.
Doesn't matter. So everybody says that not everybody, but a lot of people say that the truck exerts a greater force on the car. We were talking about this. One way to look at this is kind of as a misconception that students have. But then in this paper, the David Hammer paper, he's talking about it. Well, it might not be a misconception. It might be something else. It might be something that I can't remember the exact word, but maybe a bigger thing does more of something.
Right.
Right, and he actually talks about what we talked about last week, is that what is that more? It might be the force, but it might be the acceleration. And the acceleration is right, or fits the scientific model, whereas the force does not, because it contradicts Newton's third law.
Right.
And so I think this gets at what Dawn is saying, right? Thinking about how students are thinking about this thing, whether it's a specific concept that they have, or whether it's this other thing that he